For our final project, we conceptualized and programmed the inventory management control robot we call Logic. That's the line-operated guide for inventory control. Logic operates on a preset track, and by stopping at certain stop points, it's able to measure the number of boxes at each stop point by determining the distance between the nearest box and itself.
Managing inventory in a warehouse is time-consuming, prone to errors, and physically demanding. Traditional methods lead to mistakes, overstocking, and stockouts, which impact productivity and profits. Plus, human labor faces limits like fatigue and labor shortages. Here's how Logic can help. It reduces human error. Logic eliminates mistakes from fatigue or oversight, ensuring accurate records. Faster operations. It processes inventory much faster than humans, saving you time, and works 24/7. Logic runs around the clock with no breaks needed. In short, Logic boosts efficiency, accuracy, and productivity while overcoming the limits of human error.
The objectives we had with Logic were to be able to efficiently take inventory of various products in a warehouse. We also wanted it to be cost effective, so we used all parts that we had in-house, and we wanted it to be reliable. We needed it to be able to accurately count the boxes at every station. From these objectives, we were able to derive a flow diagram, and as you can see, the robot runs on a series of loops, allowing it to drive, as well as determine when it is at a station and when to take readings.
The wiring diagram shows that the digital pins 3, 4, and 14 of the Arduino connect to the LEDs, and 120 ohm resistors connect those LEDs to ground. You can also see the connections to the line tracker and the ultrasonic distance sensor. One of the challenges we were concerned about was not having enough pins on the Arduino, because a lot of them are already being used by different components of the car. So we had to use analog pin 0 as a digital pin, which is why the diagram shows the digital pin 14.
The results of this experiment are that we were able to create a code that is able to take distance readings and convert those distance readings into quantity readings so that we could tell how many boxes there were. We were also able to create a code that allowed the car to follow a track and stop when all of the bottom sensors were covered. And finally, we were able to integrate these two codes so that they would work together, allowing the robot to move, stop at stations, and take quantity readings of how many boxes there were. With some imagination, problem-solving skills, and lots of trial and error, we were able to create a robot that we are very proud of and that we think is useful and practical.